Hi everyone, my name is Thomas Kim. Today is June 4th, 2019. This is my 28th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn more about cyclic references, shared PTR, weak PTR. In my case, I used to create shared PTR by myself, and I have been using my own custom shared PTR. But I found shared PTR will be greatly improved in future C++ standard. In C++ 20 standard, atomic shared PTR will be introduced, and some standalone functions for atomic shared PTR. These functions will be deprecated in C++ 20. So shared PTR will play very important role in multi-threading programming. So I decided to film in-depth tutorials about C++ shared PTR, and also in some future sessions when I deal with more about multi-threading, I will deal with STD atomic shared PTR. This episode continues from our two previous videos, shared PTR 1 episode 26 and shared PTR episode 27. If you haven't watched these videos, please watch them. Also, to follow this episode, we need to download some source file from our previous episode. Please double-click this link, click Show More, double-click this link, download the source code. Since this episode continues from our previous episode, episode 27 and episode 26, if you haven't watched, please watch them. Click this button, Show in Folder, unzip it, click the solution folder, right-click, rename, modify like this, copy the solution or cut, then paste it to your working directory. Click the solution folder, copy the path, Ctrl C, start Visual Studio. In my case, I am using Visual Studio 2019. If Solution Explorer is not displayed, click View, click Solution Explorer. Go to File, Open, New Project and Solution. Paste the folder path, click Open, click Memory Leak Detection Solution, click Open once again. Right-click Solution, add New Project, select C++, Platform, Windows. Select Console App, click Next. Shared PTR 03, create. Right-click New Project, set as Startup Project. Right-click New Project once again, Properties. Make sure all configurations, all platforms selected. Click C++, General, Edit. Click this button, $solution, dir, include. Click OK. Click Language, C++ language standard, C++ 17 standard. Click OK. Right-click Header Files filter, add existing item, go up, double-click Include, click Memory Leak Detect, click Add. In this file, include memory for shared PTR and weak PTR, include memory leak detect. Now remove this part. In this episode, I will deal with cyclic reference or dangling reference related to STD shared PTR and STD weak PTR. We will understand how STD shared PTR calls destructor and the role of STD weak PTR to prevent cyclic reference phenomenon in our programming. In our next episode, we will implement STD shared PTR and STD weak PTR from scratch, such that we can have a solid understanding how to use these powerful constructs. These shared PTR and weak PTR will enable us to be a successful programmer in C++ multithreading. I will create a simple class person, public, private, STD, shared PTR, person, M, friend. Void set friend STD shared PTR person P. M friend P. So please understand this configuration. We created a class person and it has shared PTR of type and it is data field is friend, and we created a public function called setFriend. We take a friend. I will use it non-reference like this. Then we set shared friend like this. Now we test void cyclic reference example 1 MEM leak checkpoint. We want to test memory leak. Auto person. I say P. STD make sure the person. We make a person P. Then here P set friend P. Now we call this function copy paste Ctrl F5. So we have memory leak. Okay, checkpoint 32 byte leaked. If we want to prevent such misfortune, okay, I will copy another class. Then here, sound person. Okay. Then copy this. This is exactly the same, but I will change it to weak ptr like this. Okay. So I will copy once again. Cyclic reference, I say broken. Cyclic reference example. Now here I say sound person. Now I modified like this. All I changed is weak ptr. Now I copy this function. Copy, paste, Control F5. Now no memory leak. Okay, no memory leak. If we try previous person, we cannot avoid memory leak. See, memory leak. Now I copy this one again. Copy, pasted. We create 3 person. 1, 2 person, and 3 person. Okay, so person 1 has friend P2. Person 2 is P2 is a friend of P1 like this. P2 set friend P3. Okay, so P3, it should be 3. I will change it to 2. P3 is a friend of P2. Okay. Now here P3 has a friend P1. Okay. P1 is a friend of P3. In this configuration, P1 has P2 as a friend. P2 has P3 as a friend. P3 has P1 as a friend. Okay, so these are circular. These are circular or cyclic. Now I copy this function again and paste it here. I will disable it. Control F5. So we have memory leak again, 96 bytes. Oh, I will copy this again. Pasted it here. Broken cyclic reference example 2. Now it is sound person. Okay. Now everything is the same. I copy this. Paste. I disable it. Control F5. No memory leak. No memory leak. Okay? So if your application is not very trivial, you should not use std shared ptr as member fields. If you ever have to use std shared ptr as member field, you have to know what you are doing. Okay, now I will explain why such phenomena happens. I will copy this class. I copied and pasted it here. I changed the class name person like this, and I copied the class name like this. Now I add constructor std cout constructor person called std, and I copy once again, pasted. This is destructor, person called. Okay, so all I modified is class name, and I added constructor and destructor. Now let's examine void while cyclic reference fails. 1. MEM memleak checkpoint or P1 P std make sure the ptr, make sure the person. I created a person, so we created one object std cout. We created one person and one shared ptr. You can say p use count std, and now we are setting p set friend p std cout we still created one person but two shared PTR. P use count std and okay, we will call this function Please see if this destructor is called. Control F5. Constructor is called, Y-person constructor is called. We created one person at this point and one shared PTR. Currently, use count is 1. Here, we still created one person, but two shared PTR. Two. Okay? And memory leaked. Please note that destructor is not called. We created one person. We created only one person. Destructor is not called. Constructor is called. Destructor is not called. I will copy again. I copied, pasted, fixed person. I change all constructor name. Okay. I also change it to weak PTR. I modified like this. Fixed person. I also have to change this. Then I copy this. Paste. Y. Cyclic reference fixed. Then I copy this. I change it. I changed it here. We created one person and one shared PTR here. And we still created one person, one shared PTR. Okay? We can double check it. I copied, pasted. Now Control F5. See? No memory leak. Constructor is called once. Destructor is called once. We created one person and one shared PTR. We still created one person but one shared PTR. So destructor works properly. In this example, why cyclic reference failed 1? Cyclic reference failed 1. In this example, we called Y person. Okay? So, in case of Y person, Y person. We created one instance of Y person dynamically. And here set friend. Y person has a shared PTR. And we set one person itself. So two shared PTR is created. One shared PTR is created here. And here another shared PTR is created. So two shared PTR is created. When it goes off this block, this is local. P is local in this block. When it goes off, P has two use count. P shared PTR has two use count. Okay? So it does not call destructor, but decrement use count. At this point, two instances of shared PTRs are created. When this P goes off this block, the destructor of shared PTR of P does not call delete for the object person, but decrement use count. So the destructor of Y person is not called at all. It should be Y person. That means this object Y person is not destroyed. Y person is not destroyed because usage count is still 1. Okay? If we run this program once again, we are calling this function. We still created one person, but two shared PTR. Usage count is 2. Okay? This is 2. When P goes off this block, only use count is decremented. Okay? When P goes off this block, the destructor of shared PTR P does not call delete for the object Y person, but decrement use count. So use count is still 1. Okay? So Y person is not destroyed. So this Y person in dynamic memory in pre-store is not called. So memory leaked in this block. But in this example, let's run it once again. This is fixed. We are learning this example with a fixed person, weak PTR, Control F5, First, no memory leak. Second, fixed person constructor is called. Then destructor fixed person is called. Okay? Because this is weak PTR. Now scroll down. First, one person fixed person is created. We created one person and one shared PTR is created at this point. So use count returns 1. At this point, when we set friend P, it internally sets weak PTR. So at this point, we still created one person, but one shared PTR. One shared PTR. Use count returns 1. So when P goes off this flag, the destructor of shared PTR P decrement use count to 0 because it is currently 1. Currently 1, it decremented to 0. Since use count is 1, the destructor of shared PTR P calls delete over the fixed person that is dynamically allocated on the pre-store. So the result is that the object fixed person created here at this line is properly destroyed. No memory leaks. If we implement shared PTR by ourselves, we can have complete understanding how shared PTR works. I will give you one more example. I will copy this why cyclic reference failed to give you better understanding. I pasted it here. Why cyclic reference failed 2. Okay, I modified the function name. I copied and pasted it here. I will disable it. Now I will delete this and also delete this. Okay, so this is Y person, the function we failed to delete properly. It says to itself. Now I create at this line here std weak ptr y person wp. wp means weak ptr. Before we go into checkpoint, or we can put it here or here, anywhere, std cout use count. I say step 1. We can put use count like this. wp use count std and there. Okay, I copy this here again This is step 2, and WP P. Assign std shared PTR to std weak PTR. It does not change the use count of std shared PTR. Okay, so it should display 0, should display 0, and here it should display 1, because this use count is shared PTR's count. And I copy once again, paste it here. Now it should display 1, it should display 2, because 2 instance of a Y person is created. Okay, it is step 3. Now I copy it again. After this block, what does it display? What does it display? It should be step 4. Let's see what it displays. I expect 1. Okay. Now I call this function here Control F5. See, let's compare. At this step, step 1, WP weak PTR returns use count 0. Okay. At this point, we assign P to weak PTR. In step 2, use count is 1, because we created Y person 1. At step 3, use count is 2, because we assigned P. Out of this block, at step 4, use count is 1, because P is destroyed. At the end of this block, when P goes off, P destructor decrement use count, but does not call delete for Y person. Okay, so after this block, use count is 1. It explains what happened inside the shared PTR. I will copy this function. Copy and paste. Weak count managed separately. And I copy this function name, copy, and paste it here. I will disable it. Now I change it to fixed person. Fixed person I modified once and modified twice. Then everything is the same. Okay. Now we are testing this function. Control F5. Now let's examine. I will close it. Also close it. Here, step 1, use count 0. As step 2, step 2, here constructor is called because we created one instance of fixed person. At this point, step 2, use count is 1. At step 3, we still have use count is 1, even if we assigned P, because fixed person use weak PTR inside. Okay? And at the end of this block, this P is destroyed. So after this block, step 4, use count is 0. Destructor of fixed person is called, but we have a memory leak. Okay? Now I will fix this memory leak like this. WP reset. Okay? This freeze memory for use count and weak count. Okay? Now if we build once again, I will close it. Control F5. Now use count is 0, no memory leak. Okay? At the end of this block, when P goes off, P's destruct is decremented use count to 0. So STD shared PTR P's destructor calls delete over fixed person. That means no memory leak. This example displays memory for use count and weak. This example explains that STD shared PTR has two internal pointers. One pointer is to manage the allocated object. In this case, fixed person. Okay? Another pointer is to manage use count and weak count. These two pointers are managed separately inside STD Smart PTR. I already implemented complete shared PTR. I implemented shared PTR from scratch and also weak PTR from scratch. So in next episode we will implement both Smart PTR and weak PTR from scratch. Then you can have complete understanding how shared PTR and weak PTRs are working together. Shared PTR plays very important role for multi-threading in C++. So even if this episode seems quite challenging, please try to all these code by yourself. Okay, I haven't missed a single step in this video, so try to follow, type in these C++ code by yourself and examine them. In next episode we will completely implement shared PTR, and weak PTR. This implementation will help you to have complete understanding about modern C++. Please subscribe to my YouTube channel. Thank you for watching.